Welcome to the session. Today, we're going to talk about an introduction to Teselagen's design platform. You already have your access, and we're starting to create in this instance that Eduardo is going to tell you a bit more about how to use it, about how can you make the most of this platform. And well, this is, of course, brought to you by Teselagen, one of our partners for this first edition of the design. Teselagen is a startup that is creating computational biology tools for the design, build, test, and learn engineering cycle. They will tell you a bit more about their incredible work at Teselagen, that is a Latin American company founded silence. So are you listening to what I'm saying?
Sorry, Daniel, I lost you for a second.
Can you listen now?
Yes, I can hear you.
Yeah, so this webinar is brought to you by Teselagen, a Chilean startup that was founded some years ago and is working on creating software and computational biology tools for the design, build, test, and learn engineering cycle for biology. Eduardo is here to tell you a bit more about the work, about how can you use the platform and all the things that you can do with it. So I will stop sharing. Now, well, Eduardo, the floor is yours. Please, we also have here Juan Pablo Hurtado, who is going to help us answering the questions that you have in real time in the chat, in the same dynamics as yesterday. So we will have some time for Q&A at the end of the presentation, but if you have some questions, please write them down in the chat. Thank you.
Thanks, Daniel, for the intro. Thanks everyone for joining the call today, this workshop. We are really excited about this partnership that we are establishing with iGEM this year. As Daniel was mentioning, Latin America is very close to our heart. We're both me and Jota, who is one of my colleagues joining the call. We're all both originally from Latin America. So it's really exciting for us to be it's very exciting for us to be partnering with iGEM. We have a strong conviction that among these 25 teams, great ideas and designs will emerge, and we're very excited to help you with your challenges. So today I'll give you a quick overview of our platform with a very specific focus on our design module. And I will give you also, maybe if we have some time, a high-level overview of this, the build module, which is also very complementary to the design module, and maybe some of you might also find useful throughout this challenge. I'll try to leave some time at the end for some questions, but feel free to send your questions through the chat. Jota will help me make sure we can read your questions that you might have and address them either throughout this workshop or maybe take it offline if needed. All right, so I'll just start by showing you some slides about our platform. Just as an introduction, our mission at Teselagen is to build an artificial intelligence powered operating system for designing, building, and optimizing biological products. We're building a specialized software platform and machine learning algorithms for biotechnology. And as you probably know, like one of the greatest challenges in biotechnology in general, and specifically in synthetic biology, is that designing and developing new biological products is still very difficult, very expensive, very slow. Developing, for example, a new pharmaceutical compound can take on average at least 10 or more years and over $1 billion. And this is, by the way, doesn't affect only the pharmaceutical industry. It affects the entire biotech industry that seeks to develop the new generation of materials, food, biofuels, enzymes, vaccines, microbes for industrial use, you name it. So at Teselagen, we have we're building this platform that, as I was saying, allows you to design, build, and optimize different biological products. We like to call it an operating system because for us, interoperability is at the core of what we've been building. We might have a chance to show you something about our interoperability features, but if not, we have a lot of documentation also available under docs.teselagen.com that you can feel free to visit at any time, and you can read more about all the different modules and our interoperability features. And these interoperability features in general basically allows you to communicate programmatically from our platform to different third-party services, and also communicate with external databases and algorithms, and even lab automation equipment. As I was saying, our platform has 4 important modules that we call design, build, test, and discover. And I'll be giving you, like, before doing a live demo and workshop, I'll just show you a few screenshots of our platform module by module to give you a high-level picture, and then we will dive deeper into the design module. So our design module is built for managing and modeling DNA and amino acid sequences. And with it, you can visualize and create different parts that can then be reused for creating more complex designs, from simple molecules, DNA molecules, or proteins, to really complex combinatorial libraries. Everything in Teselagen is cloud-based, where different users can collaborate and share, their parts and their designs. And this, the design module interfaces also very nicely with the other modules, such as the build module. Every iGEM team should already have access to an account in Teselagen. We call these accounts a lab. So basically, we have created one lab for each team. Each lab can have 1 or more users, and users within a lab can be set up to be either an admin or a regular user. And there are like some things that the lab admin can do that regular users cannot, which are, for example, inviting other teammates to the lab, as well as also setting up some things that are available under the settings in the platform. The build module is what some people call a lab information management system that can manage everything that happens in the lab and in the physical world. It can sync with your existing registry of physical parts. It can also interface with lab automation equipment. It can do like a number of things that typically biologists would do in the lab. I know that the focus of this challenge is on the design side of things, but something that also the build module can do is it can take the designs, the outputs, certain outputs that come from the design module, and can very easily import it into workflows that you can define and then execute in your on the bench or in your lab. One of the features that there's a number of features, I won't go into like all the details. Something that some of our users like a lot is what we call our Bioshop tool. This is a tool that allows you to also score DNA. I mean, this is, I'm mentioning it, even though this is a feature that is available in the build module, it also can become very useful while you are designing DNA, because it interfaces with some DNA synthesis vendors like Twist. So we have enabled the integration with Twist in the iGEM instance, and it can tell you if you need to synthesize some pieces of DNA, it can give you an idea about how much this might cost, but also importantly, it can tell you if the molecule is synthesizable by the vendor. Sometimes, you know, you're trying to design something that has a high GC content or a number of sequence repeats, and the vendor, like Twist in this case, will give you information back to the platform telling you why your molecule might be hard to synthesize, and then you can adapt your design accordingly. Then we have our third module, which is our test module, which is a biological data depot that manages experimental results that can then be linked to the experimental workflows or molecules or designs. So after you run the experiments, you typically collect data. Actually, in many cases, this could be, depending on the nature of the experiments, it could be a lot of data. So this module helps you organize that data that typically speaks to the phenotype of your biological system. And it has like a number of tools for creating different data parsers that can very easily take spreadsheets or different files and map the content of those files into specific assays and descriptors and measurement types and so on. So the data that you're ingesting is ready for example, training a machine learning algorithm. And then finally, we have the Discover module, which is where you can train different algorithms based on the information that you have in the platform, and that characterizes the designs and phenotypes of your experiments. We classify these models into predictive models, evolutive models, and generative models. Also, you can interface the platform through a number of tools with your own algorithms. But yeah, this is something. These modules are a little bit out of the scope of today's workshop. But I just wanted to give you kind of like the high-level picture of what is it that we are building and enabling through Teselagen. So before I continue, let me make a pause for a second and ask if there are any questions so far. You can write your questions through the chat if you have any.
Please, if you have any question, you can raise also your hand.
And Jota will help me, will interrupt me if there are questions that I can answer. Jota, anything, or should I continue?
Yeah, I think we can continue.
All right. So let's dive into deeper into the design module. Now you should see the Teselagen platform. Basically, here you have on the left you have a module switcher where you can switch from one module to the next one. Right now I'm sitting in the design module. I'll switch for a second into the build module so that you can see that the top level The top menu will change. You know, we use distinct colors for each one of the modules. The design module is the blue one. And here's, you can do like in the design module a number of things. The fundamental role of the design module is to is the accurate capture of the designer's intent. I'll show you a few tools that we have to create designs in a second. But we offer a number of, basically this design module provides a unified interface and compute infrastructure for the design of DNA libraries, for the generation of instructions for how to build those designs. Those instructions can be generated by our proprietary technology that can be optimized for both humans and for automation. And the design module provides a standardized way for tracking also the relationship between the design elements, the DNA parts, the annotations, how they fit into specific designs, the protocols associated with the designs. We support a number of assembly reaction types, including what are known as type 2S endonuclease type of assembly reactions like Golden Gate, which you might be familiarized with, or Moklo. We also support flanking homology, DNA assembly methods like Gibson, which is one of the most popular ones. And there's like a number of features that we also provide to support the design process, such as, for example, being able to create design templates that can be reused across designs and so on. Some important features before I start showing you like a very specific example, because I'll show you a simple example. We don't have too much time to go into like really complex combinatorial designs. But one of the features of our design module is that you can design from very simple DNA constructs to really complex combinatorial libraries. So, designing complex combinatorial scarless designs can be accomplished quite easily through Teselagen. And I'll show you like a simple combinatorial design in a second, but it will be a relatively small one. But when you're like thinking about your experiments, what we see like in the real world, when biotech companies are using the design module, they're not like designing one construct at a time. They are like typically designing complex libraries of hundreds, if not thousands of possible constructs simultaneously. All right, so let me jump into like a specific example. And just to give you some context, like one modern industrial cloning techniques, one of the nice things that have happened is that these new modern cloning techniques have made the construction of very large stretches of DNA much easier. Now you can like assemble together like in a single pot reaction like a number of DNA parts and multiple fragments. One of these methods that I was mentioning that enable like this new type of modern DNA assembly techniques is the Gibson method, which I'll show you like a simple example right now using Gibson assembly. So let me start by going here. If you go to the top menu, you will see that in the menu we have the molecules menu. Here under molecules, you have you can see DNA sequences. You might have like a few DNA sequences that you can easily visualize and import. You have this concept of DNA parts that I'll introduce in a second. You can also handle amino acid sequences and parts. So in many cases, many users think everything in terms of DNA. But pharmaceutical companies, for example, or people designing proteins, they might think in terms of amino acid sequences and parts, and then through some back translation tools, then you can easily map those amino acid sequences back into DNA, and then generate instructions to assemble these DNA libraries. Here under designs, you can visualize designs that you might have created. So here I have like a demo account here. I don't have much information here, but let's go ahead and create a new design. When you create a new design, you can create a blank design, and I'll also show you in a minute how that works. But in the meantime, let's create a preloaded example. So let me open this combinatorial Gibson design. Here you have to give it a name. Let's name it iGEM design 1. So here, like this demo example will populate the design. This is what we call the design editor. It will populate it with a simple combinatorial design consisting simply of a vector backbone coupled to 4 possible inserts. In this case, a set of 4 antibiotic resistance genes. So basically each column in this spreadsheet, if you will, encodes a specific genetic element, and each row encodes different variants that you can use for this specific, in this case, resistance cassette. So this simple design already encodes a combinatorial library of 4 possible constructs, 1 times 4. We could add more columns, if you will, in this design editor to concatenate more genetic elements and add more like parts per column, and quickly multiply the complexity of this combinatorial design. So in the next two, I'll show you another example in a few minutes to build a slightly larger design. But for now, let's stick with this simple design, and let's select this specific DNA part. When you click each one of these parts, you see like a high level overview here on the right of the part, some basic properties, and if we double click on the part, you will see this editor, DNA editor or vector editor, that gives you like more specific information about the sequence of the associated with the part. So the part is here highlighted on the top left. The corresponding sequence is highlighted, and associated with each DNA part, there is also typically a longer sequence where the part is being sourced from. So there is a larger plasmid where this part is coming from that is also shown in this editor. This purple annotation is marking, this specific part that then will be PCR'd out. It will be amplified out of this plasmid and then cloned into the new vector backbone that was specified in the original design editor. So note that here we're introducing a new concept here, which is the notion of a DNA part. Basically within our design paradigm, a part is simply a stretch of DNA that carries this designation of part and is allowed to be put into designs within the design editor for building new designs. So if you haven't created DNA parts, you won't be able to reuse them and create more complex designs. These are kind of like the building blocks of more complex designs. And the reason for creating this, this concept of DNA part is very pragmatic. Basically, this is the part, DNA part is what will be used by our algorithm, and it will tell exactly our algorithm what DNA is it that you as a designer would like to see in the final output construct. Parts can be created in several ways. You can you can create them one by one in the design module, or you can upload them in Masse as GenBank files or FASTA files. We have like a number of tools for easily creating DNA sequences and DNA parts. And I won't go into all the details, but we have a lot of documentation around this on our website. Yeah.
So Maria Fernanda asked a very good question. I think it's relevant for everyone. So she asked if Teselagen can help us to can help everyone design primers for PCR.
Yeah, very good question. And actually, I'll show you in a second how this could be done. Like typically, people do it in the context of a more complex protocol, like a DNA assembly protocol, where part of the protocol might involve PCR amplifying some parts, but we have primer design tools that run in the backend of our platform, and it will when you run our algorithm, our J5 algorithm that I'll show you in a second. The report of that algorithm will show you, will calculate, design these primers for you, also based on some default settings. And I'll show you in a second also how you can change those settings if you will. But yeah, like the short answer is definitely that's possible through Teselagen. And after you design them, you can also save them in our typically people save them in the oligos library. All right, let's go back to the example, simple example design. So here, like we have all these parts that are using this design. I mean, here the parts have been created for us already, so we have no need to do it again. But it's very easy to, as I said, to create like parts through the part library or through the vector editor. Let me now you see that now, we have this green button here on the right, top right. So this is it's very tempting for us. We could like click this button now and generate instructions to assemble this combinatorial library. When we do it, when we run like this this button, there's a lot of checking that is done behind the scenes that I can like show you in a second. But before we push this button, let's do a few more things in the design editor. And there are like a number of things that you can see here in the menu that are probably like self-explanatory. Maybe there are some icons here on the right that are maybe less obvious in terms of what they do, right? Like, so the first one is this, design details icon on the top right. So this will basically bring up general information about the design as a whole, giving you the option to change the name of the design, add the description, modify the design layout, also choose whether you want to exploit oligo reuse and so on. So again, like there's like I know the focus of this competition is on the design side of things, but once you are like building something, many times you want to be aware of the parts or the oligos that you have already synthesized and designed and that are available in your freezer, so that you know that they can be reused if needed when generating these protocol instructions. The next menu item here on the top right is where assembly reports derived from running the design through the design algorithm are listed. Right now there's nothing because we haven't like run our algorithm, our assembly protocol algorithm. But after we do, it will show you something in a second. Then we have the assembly reaction details, which specify what type of assembly method we are using for this assembly, as well as the assembly parameters. So in this case, that the example is already loaded up, it shows the correct assembly method, which is Gibson style type of assembly. Note that these are all common names for a set of assembly protocols that are more accurately described as flanking homology methods, which Gibson is probably the best known. We also see a way to, here below, to set up the naming templates. So all the constructs that come out of these assembly reaction instructions are automatically generated and make sense for you to then be used in a downstream stage. The next item are like these card details. This is, again, like this is like a more advanced feature. This is more useful when we are like designing more complex hierarchical designs. But since this is a one level type of design and not a high hierarchical design, we can ignore this for now. Moving on to the next item, the bin details. Here's where we see information that has to do with here, like we are highlighting this resistance cassette genetic element. So here we will see, the name of this bin and also again some like advanced features. There's like a number of like parameters that you can like set up here, and we have these tooltips that you can hover the mouse with and get more context information about all these more advanced parameters, if you will. The next menu item below it is the part details, which basically it will give you details about the specific part that you can select. Then below it you have this junction details. Again, this is like a more advanced feature. Finally, you can see comments associated with the design. While you're designing, you can write some notes and use this kind of as a also electronic lab notebook, if you will. And then finally, we have also like another cool feature that is, used by some groups while they're designing something. They typically want to get approval from a peer or from a colleague, so you can submit your design for review, so that a colleague can go ahead and review it and approve it. And there are a number of things that I won't go like into much detail here, but if the team admin or lab admin goes to settings, he will have access to a number of settings that he can configure here, including this design review process. And you can like add like different design review steps that then can be used in that feature that I was just showing. Any questions so far? Jota, no?
No, at least on the chat. There's
Okay.
no questions.
So can we like click this submit for assembly button? Yes, let's do it. Let's click it. You will see this little message popping up that is saying that this design was submitted for to our assembly DNA assembly protocol that will generate the instructions to. It will basically compute if this specific DNA assembly strategy involves the use of any PCR reaction, or if you need to synthesize any oligos or any primers. Everything will be included in a report that will be generated after you click this button. So the report is ready. If we click here on the assembly reports, now we see that there is one report available associated with this design. So if I click it, you will see that there's like a number of things that are included in the report. And I'll also spend like maybe the next 5 minutes quickly going over like how this report is structured. Before doing that, let me load a slightly more complex design. So instead of like loading I'll go to designs, I'll create a new design. You can always go and create like a blank design and choose a lab here. And then you can, as I was saying, you can kind of like add like more, if you will, like genetic elements to your design and variants and so on. And if you double click a blank part, you can choose, you can start populating your design here, if you will. But let me go and create another simple design based on the examples that we have preloaded. To save some time, I'll create a simple combinatorial golden gate design. iGEM golden gate. Combinatorial golden gate. So this is a slightly more complex design. Here, basically, we have 6 genetic elements. We have a vector backbone. We have 2 possible signaling peptides that you can that we want to test. We have 2 linkers, that a long one and a short one, that also you can test. We have the main component is a GFP gene. And then we have a degradation tag in the 3' end of the GFP gene. So this design is encoding 2 times 2 times 2 equals 8 possible constructs. I will submit this, and again, like here, like the assembly method that was chosen was a golden gate assembly. There are like a number of parameters associated with this strategy that you can eventually also modify. That you know, the default parameters typically work fine for most of the users. And we will submit this this design for assembly. We'll have to wait a few seconds. And as soon as it is completed, I'll open the report and kind of like quickly go through the report to show you what we see. You can always go here to DNA assembly reports and see the reports that have already been generated. This is the last report that we generated that for the simple combinatorial Gibson design. Actually contain like a few warnings. When you see warnings, you shouldn't like be so worried. Like typically users get worried when they see errors. When there's like something really critical in your design that will not allow you to assemble it properly, you will see like here like a warning with a red mark. Here we have just some low level warnings, some medium level warnings associated with the design, but for now we can ignore this. If I refresh this, view, I should see the last report, associated with the Golden Gate design that just completed with no warnings. Let me open this one. So let's take a look at this entire, report, which is, pretty detailed. So the report starts, with information about your design, the assembly method used, the time it was run, a number of like different exporting options that you have for exporting this this report, and if there is any warnings. In this case, there were no warnings, and then following this, descriptive data. The report is sectioned, as follows. First, we see these pre-built constructs. The pre-built constructs, in this case, there's nothing. These are particularly useful for more complex designs, which we call hierarchical designs, because it will show you the kind of like intermediary constructs that needs to be built before like building the final constructs. In this case, this combinatorial design is simple enough so that we don't see anything here in this section. Then remember that I was showing you that this combinatorial design was encoding 8 different designs. So these 8 different designs is what we see here in the assembled constructs, or output. This would be the output constructs that you would be generating if you assemble this combinatorial library. If you double click, like any of these constructs, you will see how each one of these final constructs would look like, and you can inspect it. Like all these annotations are preserved from the original DNA parts. So many times, visually inspecting how the final construct will look like is pretty useful. Then going back to the report, we have this input sequences. So as the name suggests, input sequences are the sequences of parts that we are sourcing from somewhere else. In this case, we are not reusing any input sequence outside of outside the PCR reactions that we need to run. So this section is also empty. What we see here are the oligos that are associated with this DNA assembly protocol that we're running, that were computed for you, and you know that you can order from your favorite DNA synthesis provider, and you can also, you have here the option to save it to your oligo library or export it. You can also export it as a CSV file. But here you should be able to view the sequences of each oligo, as well as a number of you know, parameters associated with each one of the oligos. Again, like annealed oligos, there's nothing for this specific reaction. This design doesn't use annealed oligos per se. Then we have this section of symptoms. You know, this name comes from one of our early customers that simply called synthesized DNA fragments. He called them symptoms. And so, you know, we like the name, and it stuck, you know, in our platform. So these are basically DNA pieces that need to be directly synthesized. Typically, like longer DNA fragments to be synthesized. Importantly, like this section of PCR reactions, this one will show you all the PCR reactions that need to be done in order to assemble these constructs, as well as the properties of these reactions. So this is, you know, very, very important and useful information for this protocol. And then finally, we have like this, like tables of, we have the assembly pieces. The assembly pieces are like basically a list of fragments that you have to put together before basically generating the final constructs. And then finally, the assemblies, which is basically, it's like the final DNA library that you're building. In this case, you know, given the design is relatively simple, you know, assemblies and assembled constructs are, it has very similar information, but for more complex hierarchical designs, you will notice that there are some differences between what is contained in one table and the other tables. And you can always, you know, as I was mentioning, you can always hover the mouse over these tooltips to kind of like get some information about what this view or table or field is all about. Any questions so far about like these reports? And this is at the core of like what a lot of people that are doing synthetic biology in practice do. You know, they go to the whiteboard, you know, which we call our design editor. They design either a simple design or a more complex combinatorial design made of like different genetic elements. And then they basically run like our algorithms to generate instructions to see if this design, how easy it is to then proceed and build the design in the lab, you know, which is, you know, where like most of the challenges many times happen. So this algorithm helps, you know, users save a lot of time and give you guarantee that this is a good design. So I think it's very important for you when you're designing anything to make sure that, you know, it's a good design that can then be easily built in the lab.
Eduardo?
Yeah.
Just a couple of questions that have come. I've been answering them on the chat, but for example, there was one from, I think it was Anna. yeah, she was asking about how do you get your sequences, like vector sequences, into Teselagen. So maybe you can show a little bit of that. Yeah.
Yeah, sure. So here, this is our sequence library. So the first thing is to make sure you have some sequences, right, in the sequence library. And there's like a number of ways to generate, to import sequences. You can simply, okay, let's give it a name, sequence one, demo lab. You specify, we have this attribute to tell our system if it's a circular or a linear sequence. Let's assume it's linear. You can add specific tags that will help you then filter and easily discover and find your sequences, because in practice many times users are managing sequence libraries with like thousands of thousands and thousands of sequences. So adding some tags sometimes is useful. Okay, let's say this is a demo sequence. Let's save it. And here's like, you can easily, like add like nucleotides to the, so yeah, you can here add A, C, C, T, G. You can do it manually. Or you can, if you have like really long sequences and many of them, you don't need to do it manually, but sometimes you can like easily, either enter it manually or copy paste it from somewhere else, or you can upload it. So we support like a number of like formats. Maybe it's too small for you to see, but we support like FASTA files, GenBank files, which are the most popular, like text files, SnapGene files, which is like another tool that a number of people use also. So you can either create it manually, you can upload it through files. We have more advanced features. You can like import it from an external database. This is a more advanced feature. I don't think we have, we have like a demo. We have, in order to use this feature, you would have to go to settings and configure our integration server. So we have a very powerful tool, that has also like a very nice user interface where you can, drag and drop all these, boxes to create what we call a flow, an integration flow that can hook an external database or like, let's say, a public database like NCBI, where through this integration server, we can use the API of, let's say, the NCBI database, do some queries, pull sequences from an external API, and then use our API to easily import those sequences into the sequence library. We are like this at the moment. We are making available a number of integration flows for the community to interface with some of the most popular public databases. This is an example of interfacing with a database called ICE, which is hosted at the Joint Bioenergy Institute in Berkeley, California. If any of you have interest in interfacing Teselagen with public databases and registry of parts and sequences, let us know. Maybe there's like an opportunity for us to also work with you to publish some integration flows. Maybe give you some help, or if you can help us build some of these integration flows, we can definitely make them available for the community and give you credit on our company's website.
Eduardo, there's also another question from Jose Andres. he's interested on the reviewing functionality. So maybe you can show him how to set that up. Basically, if you go into the design settings, Eduardo?
Yeah. So there's an article. I won't go into much detail for the sake of time, but if you have like questions, go to docs.teselagen.com. And then here I search our knowledge base, I search review. And here, like the second article that I found is called design approval process. So there is some information about how to set up this. If you can see, can you see? So I would like, recommend going through this article. If you happen to, want to do something and you go to the knowledge base and you don't find clear information about how this can be done, let us know. You can send a message to Daniel or send me a message. And we will, if we don't have, covered that, feature through in our knowledge base, we will make it high priority to document it and of course, try to help you in the short term before publishing new articles. What any other questions that we might have?
No, actually, you answered two good questions. You answered two good questions. You showed the docs and the review. So yeah.
Yeah. So here, here I'm on the sequence library. You can there's like a number of things that you can if you right click, always see if by right clicking on an entry in the library, you will see typically you will see this kind of type of context menu to either visualize this sequence, open it in a new tab, rename it, delete it, tag it, a number of things that you can typically do from the context menu. You can also many things you can do in bulk, you can choose multiple sequences and you might want to tag them all at once, so here I chose, 6 sequences. I could add a tag to all of them, I won't do it. I don't want to mess too much with the existing, data. Also, you can do filter, right? You can sort and filter. Let's say we want to search for sequences that are less than 35 base pairs long. Boom! Here we get these sequences, only short sequences. So there's a number of things that that you can do using our tools. We have also this DNA alignment tool, sequence alignment tool, where you can create new alignments. Maybe you want to use your sequences to do a multiple sequence alignment or a pairwise alignment. So we also have some tools for doing some alignments. You can switch, some developers, particularly software developers, they love working in dark mode. So you can switch from light mode to dark mode with this icon. Here's where you will see, all the notifications. Typically, this come from, running our assembly instruction generation protocol that we call J5. Every time you run, you start or J5 or J5 finishes and generates reports, you will get a notification. We have this global search tool. Here you can search, entities across, most libraries in Teselagen. You might want to search something by a tag or by a name or by a barcode, So this is a very powerful search tool that we have enabled. Something, I know we are maybe running out of time, and I was thinking maybe I would have some time to show you the build module, which I haven't. They're all these three other modules that I haven't had time to show you in detail. But here's where you can define and execute experimental workflows. So let's say you have a design, you generated like you're trying to assemble a combinatorial DNA library. You already generated a report that contains instructions to assemble it, including all the PCR reactions that you need to run, all the primers that you need to synthesize, and so on. Then you can like execute an experimental workflow. Here I have, just before this workshop, I quickly created a simple workflow that I call DNA assembly workflow. iGEM workflow, I'll give the name. And I'll show you very quickly how this looks. Basically, this workflow is composed of 6 different steps shown here on the left. This workflow has basically been was defined previously by me, but you as a user can very easily go into the settings section and define your own workflows. And we have, when you're like designing a workflow, we have a number of tools that you can use and basically compose. You can compose all these different tools to create a more complex experimental workflow. But for the time being, just let me show you this simple workflow where I can actually run it very quickly to give you an idea of how this works. I'll start these tasks. The first task is to choose constructs that I want to build. So I'll use this report that I just generated from the Golden Gate design that I just showed you. So after I load this report, it will show me all the assembly pieces that I could build. So I'll choose them all. I'll tell the workflow that I want to actually build all 8 final constructs, and I'll choose the default names for the output datasets. Then I'll do some basic PCR planning, and I'll do a quick inventory check. Again, I'll choose the report that I generated from the design module that contains information coming from the PCR reactions that I want to use. I'll, specify that I want to do all these PCR reactions. This tool will tell me how I want to basically place the reactions within the plate. Here you can do some optimization. You can distribute these reactions in different ways across the plate and in different zones depending on your PCR machine that you're using. I'll simply choose the default method. And here's where we're kind of like linking the theoretical world of designs and theoretical constructs with the physical world. And again, like maybe this is not so relevant for you for this design lead, but here's where basically the tool is trying to see if I already have in my inventory plasmids and oligos that I would need to run these PCR reactions. So actually, given that I was playing with this workflow this morning, I already basically included all these materials in my inventory. So I can now basically, say, choose all the plates where I want to source all these materials. And now I will basically, I'm ready to run the PCR. So here I will, one of the previous steps already generated for me a plate map that basically maps all the kind of like the inputs for each well, like namely the DNA templates and both the forward and reverse primers, to the specific wells where the PCR reaction will take place. I will choose also some tables that come from one of the previous tools. Now I'm ready to run the PCR. I'll specify some default volumes. Let's say 5 microliters. And I'll execute the PCR reaction. So you can take what this tool is doing. It's generating for you a work list that I'll show you in a second, that contains all the instructions that you need to run these PCR reactions. Basically the source plate, the source position, what is it contained in that well, where is it, where should I move this this material, and how much volume should I transfer. And then I can take these instructions and then I can either execute them manually. I'll choose the work list and execute it manually. Or I can also export this work list to some equipment that I might have, where the equipment, the lab automation equipment, will run all these reactions for me. So this is like a more advanced feature, but basically you can see this work list that tells you how to run the PCR reactions, and you can export it to a number of different lab automation equipment that you might have in your lab or in your company. And then you can, like, the robots will do the work for you. This is how it works in in any kind of like company. Most companies, from small to larger companies, are using automation equipment that automate all these reactions for you. Yeah, I won't go into again like too much details about this module, but I hope give you like some idea of like what would happen. What would be the next after you have designed something? What is it that you would typically do after you are like ready to go to the lab and define and execute some experimental workflows? Any questions so far? I think we should be. I hope this was useful and gave you like a good high-level overview of the design module, particularly. But again, you can go into the platform and play with some of the other modules and features if you will.
This can be very useful for you guys, specifically the build module, because of one of the requirements that you have. You need to propose the protocols that you will use, the experimental protocols that you will use in the build phase, that you can go and explore, and maybe you can find really useful information for you. Well, yeah. So we're receiving some questions, Eduardo, regarding if we can do another workshop where we go a bit deeper on the applications and maybe check some case study.
Yes, definitely. Let's do that. Happy to do it. So, yeah, let's. I'm open for doing that. You know, it can be like an hour, you know, maybe like a 1 hour long session where I can go over some examples, like how people are doing synthetic biology in practice. You know, like designing and building and optimizing the metabolic pathway, which is typically what companies in industrial biotechnology would do, or some applications in pharma. So more than happy to go through some specific examples in a follow-up workshop.
That's perfect. I will reach out to check the possible date for this. I will let you know. So if any of you guys have any questions related to things that Eduardo showed you, please go ahead. And I know that you're having problems when creating the lab users, so we can check also that.
Yeah, happy to help you guys with that offline, and make sure that everyone can have access and is set up for using Teselagen.
Well, I think you should go explore, play some with some of the tools, and if you have any specific questions, you can also let us know, and we can address them in the next workshop. Exactly. So some questions will come up during the process.
A final comment. I think I didn't like mention this really, but so each group, each team will be assigned to a specific lab, and then the name of your lab will you know correlate to your team's name, and also you can if you I think by default you might your projects your designs are not associated with any project, but I strongly encourage that if you don't see any project within your lab, to create also one or more projects and associate your designs to specific projects. So basically, yeah, like within a lab, you can have different projects, and there are some advantages for having all the sequences and designs associated with specific projects. If you don't have them associated with projects, for some specific tools, it might be an issue downstream. So yeah, that's something I wanted to mention very quickly.
Great, that's awesome. Yeah, you should also explore that possibility.
To help, you know, I know like this was, you know, we covered a lot. There's probably a number of questions that will come up, you know, as you use the platform. Feel free to reach out and help you answer any questions you might have.
Any other question, guys? If not, please don't forget filling out the feedback survey that Nathan just shared with you. You will find the link in the chat box, and we will also share the link with you in Discord channel. Diana Lopez, go ahead. You're raising your hand.
Hi, nice to meet you. Thank you so much for the excellent presentation, and thank you for this workshop. I was actually just wondering, what would you consider was the main challenge during the creation of Teselagen?
You mean challenge the creation as a Teselagen as a company, or the
exactly.
product? Well, yeah, when you create a company, everything is a challenge. Building a product, hiring, fundraising. So yeah, I think everything has been challenging. Like yeah, I would say like and for us, the team, finding a good team is really important. we are like basically we're kind of like working at the interface between software, synthetic biology, machine learning. It's pretty exciting, you know, to be working on like a field that is growing very fast, and we're all very excited about, you know, what the you know, the field will all the products that will come out of synthetic biology in the years to come. But it's also finding, you know, good people that are good software engineers or data scientists, which is mostly what we do, and simultaneously like and understand biology and genetics. That's, you know, that's always, you know, it's always challenging to find good talented people. Initially, you know, like getting a company off the ground with little or no revenue and no funding, you know, can be a challenge. Like in our case, we were able to bootstrap, and we received significant support from the United States National Science Foundation, and that really helped us. And then we built, you know, the first version 1.0 of Teselagen. Now, you know, what you see right now is like version 3.0, but the first version was, you know, we only had like a basic version of the design module. We didn't have the build module, the test module, the discovery module. And but we were able to, you know, we were really focused on covering some specific use cases that no other platform was covering, and really, you know, started like attracting users and companies, and that way we were able to like bootstrap the company. But, you know, it was a challenge to decide how much we should focus the effort on what we build. And because, you know, the more you focus, you know, the more you can differentiate, but you're narrowing down maybe the scope of the work that people can do in your platform. But we were like we were very focused on design, and then as we grew, we started extending into build, test, and discover. So maybe that gives you like a flavor of some of the challenges that we've encountered. But
Thank you so much.
it's been challenging, but gratifying at the same time.
Thank you for your valuable time.
Yeah, you're spoiling us. That was a great question, but we actually will have a live interview with Eduardo. I think it's on Friday 20th, if I'm not wrong, where we will hear about the story of Teselagen, and also the path of Eduardo while becoming an entrepreneur, and also about his vision about synthetic biology. So this is going to be in the same webinar series than the one that we have with Mariana Matus this Friday. So please stay tuned, and we will let you know the details about that. But thank you, Diana. It was an excellent question.
Yeah, thanks, Diana, and also like feel free to reach out, and, you know, if you want. I'm LinkedIn. I don't use Twitter very much, but I mean, some of the social platforms, feel free to reach out and add me, if you will, to stay in touch.
By the way, Diana, I think we have a little problem with the account of your team here to Snatchers. But let me check, because I think we have some issues with Rafael's mail, but we'll let you know. Catherine is asking where can they have access to the recording. We are sharing this through Discord, so it takes some time to process. But in 1 or 2 hours, you will have it. You'll have the link in the Discord channel. I think it's in announcements or events. I don't remember, but just be aware of your Discord channels. And well, I think that would be all for now. Do you have any final comment, Eduardo?
Thanks again for the invitation, for the opportunity to partner with iGEM. Again, like we are like very excited about this new design league, and you know, looking forward to see what designs you guys will come up with, and continue to be in touch to help you throughout this challenge. So looking forward to staying in touch, and we will follow up and do again like another workshop, and also like another chat with Daniel to talk more about the company and the journey of Teselagen.
Thanks a lot for your support. We love to have you as partners in this first edition of the Design League. And well, thanks also for continue fostering the development of synthetic biology and biotechnology, not just in Latin America, but in every single part of the world. You're doing an amazing job.
I think we can, there's a lot of, talent and good ideas coming from Latin America. So this is, like the opportunity for everyone to try to come up with the best ideas, the best designs, and basically show the whole, the global iGEM team and the whole world, what ideas can come from Latin America. So
we're very excited about this, and I think we will be surprised by the quality of the project that we will see in the finals in November. Before we go, remember that this design platform from Teselagen is one of the tools that you can use to help you design your projects, and also to help you checking the box of the silver medal requirements of computational biology. It requires you to use at least one computational biology tool to validate your design, to help you designing your constructs, your genetic circuits, genetic devices, and also to gain more information on your systems. So, as you know, you will have access to these features, and we will be there to help you during this process. And just an announcement for tomorrow, we will learn how to use other tools, mainly open access tools, and we will learn some bioinformatic applications to genomics with Ana Castillo, the first of our webinars presented by the whole biotech community. So tomorrow, just remember, is 1 hour later than this one. It is 6 Eastern Daytime. So that means 7 for most of Brazil, 5 for those in Mexico. Thanks a lot, guys. Please, if you have any question, comment, or thoughts, share it in the chat or through the Discord platform.
Thanks, everyone. Thanks, Daniel.
Nice afternoon or night.
Okay, thank you. And bye.